The starting point for enterprise marketing campaigns is the brief. It is usually a chaotic, unstructured block of text that teams must somehow translate into dozens of targeted deliverables. Scaling this process up to enterprise levels requires treating that text as raw material entering an automated assembly line. Look closely at a real marketing brief. It is a messy collision of SKU codes, visual layout instructions, logo requirements, and vague creative directions, all jumbled together in a single paragraph. A human copywriter has to extract the relevant facts from that paragraph and multiply them. Writing unique copy for 5 different audience segments across 3 distinct channels means generating 75 separate pieces of text. Taking that messy paragraph and dumping it into a single prompt for a standard large language model will fail. It cannot consistently produce 75 brand-safe, perfectly formatted variations in one shot. Achieving true enterprise reliability requires breaking that single prompt into a specialized, multi-stage AI orchestration pipeline. The architecture driving this system relies on a fast API backend. It orchestrates specific tasks between Azure OpenAI and Google Gemini models. Before making any API calls, the system executes a preliminary check against an AES-encrypted Snowflake database to see if this exact brief and audience combination was already processed. Next, it passes the request through an input validation layer. The requested audience and channel are checked against hard-coded Python whitelists to ensure they match approved internal categories. This fail-fast validation pattern protects the system. It guarantees that malformed requests are rejected immediately, preventing bad data from triggering expensive, time-consuming AI execution cycles. The validated request enters Stage 1, the data extraction worker, powered by Azure's O3 Mini. This model has a singular objective. It takes the chaotic input paragraph and forces it into a rigid 11-field JSON object. The prompt relies on negative constraints, excluding identifiers like SKU codes. It forbids verbs in the product field to ensure clean formatting. A hallucination guard prevents guessing. If the brief lacks an athlete, the JSON field remains explicitly null. By isolating specific variables from the initial chaos, Stage 1 creates a safe, highly structured data payload for the rest of the pipeline to consume. The extracted JSON is clean, but it lacks external context. Stage 2 provides web search enrichment. The system invokes Google Gemini 2.5 Pro, utilizing native Google search tools to dynamically research any athletes or figures mentioned in the JSON payload. To prevent context window bloat, the prompt strictly limits the search return to exactly 2 short, concise points of information. A second query targets the product itself, forcing the model to scrape key features exclusively from the brand's official US e-commerce website. This search grounding process validates the payload, anchoring the AI's creative generation in verified facts and brand-approved messaging. Stage 3 introduces the core copywriter agent, where 3 distinct streams of data converge into a single O3 Mini processing node. The node ingests the enriched JSON payload, target audience personas, and formatting guidelines. LangChain's pedantic output parser ensures the resulting copy fits exactly into a predetermined schema of arrays for headlines, subheaders, and CTAs. To maintain variety across different customer segments, the system performs a cross-audience cache lookup. If the system previously generated text for a different audience using this exact brief, those specific outputs are actively injected into the new prompt as negative constraints, explicitly telling the model which phrasing to avoid. The agent operates under a strict invisible adaptation rule. It must use vocabulary suited to the specific audience without ever explicitly naming that audience in the text. By combining creative text generation with rigid mathematical boundaries, this stage guarantees uniqueness across every demographic. The output then passes to Stage 4, an automated editor agent designed purely for quality control. The editor scans the generated headlines to identify obscure or complex words, replacing them with more accessible, standard alternatives. It then performs a final comparative check, measuring the new copy against all other audience segments to absolutely guarantee distinct phrasing. Generating 5 unique headlines in isolation is simple. Scaling that up to 75 mathematically distinct variations requires a dedicated, automated second pass. The final station in the assembly line handles CTA standardization. At this point, generative AI models are completely removed from the workflow. Instead, standard Python logic takes over, evaluating the available product data through simple if-else rules to predictably append the word shop to the capitalized brand or product name. True enterprise reliability means knowing exactly when to abandon probabilistic text generation in favor of rigid, predictable code. The finalized JSON payload finally exits the complex AI pipeline and is rendered directly into the clean, user-facing interface. The messy, unstructured paragraph from the beginning has been transformed into perfectly formatted arrays of email, mobile, and SMS variations. This specific pipeline reduces a manual copywriting process that used to take 25 hours per week down to about 2 minutes. That level of scale is achieved by dismantling a single monolithic prompt and distributing the work across a highly structured 5-stage assembly line. Post-generation, the backend encrypts the finished payload and stores it in Snowflake with a 24-hour time to live. It also generates a comprehensive execution log, capturing the web search results and every intermediate output produced by the AI models. If an error or compliance issue occurs in production, engineering teams can trace the exact node and prompt that failed. In the next video, we will examine the React frontend, detailing the autocomplete validation layer and the UX strategies used to manage long AI generation wait times.